And for power series, we have y double prime is equal to y. And solving our power series, it is equivalent to y double prime minus y is equal to 0. And the summation y is equal to summation of n is equal to 0, positive infinity, where c sub n x raised to n. Our y prime is equal to summation of n c sub n x raised to n minus 1, where n is equal to 1 to positive infinity. And our y double prime is equal to the summation of n times n minus 1 times c sub n x raised to n minus 2, where n is equal to 2 positive infinity. And substituting the values of y prime and y double prime to our equation, we'll have the summation of n quantity n minus 1 c sub n x raised to n minus 2, where n is equal to 2 to positive infinity, minus summation of c sub n x raised to n, where n is equal to 0 to positive infinity, which is equal to 0. Now, after substituting, we need to balance the index of each summation. So we will balance the y double prime equation by reducing our index into 0, and as well as adding 2 to our equation. So we'll have summation of n is equal to 0 to positive infinity, where n, so since we reduce 2 on our index, we will add 2 to our whole equation. So we'll have 2n plus 2 and n minus 1 plus 2 and c sub n plus 2 and x raised to n minus 2 plus 2 minus summation of n is equal to 0 to positive infinity of c sub n x raised to n is equal to 0. And now we'll cancel this, and we have balanced the equation in which the index of the two summation equation is equal to 0, and it has an x raised to n factor. So after having this, we have balanced the equation. We will now factor x raised to n to have a recursion relation. So we have the summation of n is equal to 0, positive infinity, x raised to n, quantity n plus 2. Simplifying this, we'll have n plus 1. So n plus 1 cn plus 2 minus cn is equal to 0. And after this, we may now have our recursion relation by having cn plus 2 is equal to n plus 2 times n plus 1, in which we'll transpose negative cn, we'll have positive cn. And this is now our recursion relation. And after having our recursion relation, we'll now substitute values of n in order for us to get patterns or series. So we have n is equal to 1, or n is equal to 0. So we'll have C0 plus 2 is equal to Z0 over 0 plus 2 times 0 plus 1 is equal to C sub 2 is equal to CO over 2 times 1. And n is equal to 1. We have C sub 1 plus 2 is equal to C sub 1 over 1 plus 2 times 1 plus 1, which gives us C3 equal to C1 over 3 times 2. And n is equal to 2, having C2 plus 2 is equal to C2 over n is 2, so 2 plus 2 times 2 plus 1 is equal to C4 is equal to C2 over 4 times 3. So as you can see, there are repeating patterns of C's, constants of C's, like this, because we have value of C2, so it will be CO over 4 times 3 times 2 times 1. And n is equal to 3. We have C3 plus 2 is equal to